Alright, so let's take a look at the review for this upcoming quiz, topics 8 through 11. Number 1, we are finding the roots by factoring or finding the solutions by factoring. So we got 3x squared equals 18x. Alright, well first we need them on the same side. So let's subtract the 18x. We got 3x squared minus 18x equals 0. Alright, always needs to be equal to 0. Now we can factor the left side, so I'm going to start by factoring out the GCF. GCF is 3x. So 3x comes out. I'm left with x minus 6 equals 0. Alright, so these two factors multiplied together are equal to 0, which means that this factor is equal to 0, or this factor is equal to 0. So I just need to solve these, and I'll get my two solutions. So one of my solutions, x is equal to 0. The other solution, x is equal to 6. Alright, these are my two solutions. You can check them in the original problem. Number 2. 12x squared minus 4x equals 0. Equal to 0, so I'm going to start by factoring. First check the GCF. I have 4x. 4x comes out, so I'm left with 3x minus 1 equals 0. Either 4x is 0 or 3x minus 1 is 0. Alright, solve for x. One of my solutions is 0. 3x equals 1. Divide by 3. Another solution is 1/3. These are my two solutions. Number 2 is complete. Number 3, 16x squared is equal to 25. Subtract 25 because it needs to be equal to 0. 16x squared minus 25 equals 0. This is a difference of two squares. This is a difference of 4x squared and 5 squared. So this will factor into 4x plus 5, 4x minus 5. So either the first factor is 0 or the second factor is 0. I just need to solve these two and I will have my two solutions. So subtract 5, divide by 4. One of my solutions, negative 5 over 4. Pretty much the same thing on the other one, except I'm adding 5. So x equals 5 over 4. My two solutions, negative 5 over 4, positive 5 over 4. Alright, number 4. X squared minus 10 equals negative 3x. Well, I need the 3x on the other side because these need to be equal to 0. So x squared plus 3x minus 10 equals 0. Alright, there's no GCF. I'm going to factor this using the x. Since a is 1, I can skip the grouping part, so this will be a little bit easier. Up top is a times c, so negative 10, and the bottom is b, positive 3. So I'm looking for positive 5, negative 2. Since a is 1, I don't have to do the grouping step. I will just use these as my factors. So x plus 5 and x minus 2. So either of these are 0. So x plus 5 is 0 or x minus 2 is 0. So first solution, negative 5. My second solution is 2. Number 5, 3x squared equals 48. Does this say solve by factoring? It does, I guess because it's difference of two squares. I would personally solve this by taking square roots. We know how to solve by taking square roots, so let's just do that. It's a little bit easier. I don't know, if we don't have to factor, we shouldn't factor. So I got x squared is equal to 16. take the square root of both sides. Don't forget plus or minus. So x is equal to plus minus 4. So two solutions, either x is 4 or x is negative 4. Or, well, those are the two solutions. X is 4 and x is equal to negative 4. Those are two possible solutions. Much easier than factoring, although we could have factored. It says by factoring, but there's no reason to factor that. However, I will do it for factoring. So we would have 3x minus 48 is equal to 0. We would factor out the GCF, which is 3. So we have 3, x squared minus 16 equals 0. And then x squared minus 16 is a difference of two squares, x plus 4, x minus 4. You can kind of see where this is going. Alright, you kind of see that we're kind of getting to our solutions there. So you can do it by factoring, but it's much easier to do by square rooting. 6, x squared minus 8x equals negative 16. Well, 16 is on the wrong side. X squared minus 8x plus 16 is equal to 0. There is no GCF besides 1, so we can do our cross. Up top is a times c, so positive 16. The bottom is b, negative 8. So we are looking at 4 times, I don't know, let's see, 16. 1 times 16, 2 times 8, 3, 4 times, yeah, okay, so negative 4 and negative 4. So negative 4 and negative 4. Since a is 1, I can just shortcut this. So my two factors would be x minus 4 and x minus 4, or just x minus 4 squared equals 0. So I can just set this factor equal to 0, x minus 4 equals 0. It's the same thing as taking square root on both sides, it's kind of the same idea. So my solution must be 4. Only has one solution. 7. 4x squared plus 14x equals 8. Alright, 8's on the wrong side. 4x squared plus 14x minus 8 equals 0. Factor out the GCF. This one has a GCF of 2. So 2 comes out. 2x squared plus 7x minus 4 equals 0. And I need to factor this. Now a is not 1, so I am going to have to factor by grouping. So up top I have a times c, 2 times negative 4 is negative 8. In the bottom I have b, positive 7. Two numbers that multiply negative 8 add to negative 7, or positive 7, that's positive 8 and negative 1. So I'm going to use that to split up the 7x. So this becomes now 2x squared plus 8x, and then this is my first group, and then the second group is negative x and then minus 4. Alright, I just split up the 8x and the negative 1x from here and then grouped them. I did this all in one step to make this a little bit quicker. The GCF of each group, so the GCF of the first group is 2x, the GCF of the second group is negative 1. So I have 2x, and what I'm left with is x plus 4. I have negative 1, and what I'm left with is also x plus 4, which means these two have x plus 4 in common, so I can factor out x plus 4, and I'd be left with 2x minus 1. Alright, I need to go back to the original problem. Not the original, but I need to go back to this step and replace the x squared plus 7x minus 4 with x plus 4, 2x minus 1. So I got 2, this is this 2 right here, and then x plus 4, and then 2x minus 1 is equal to 0. This 2 is kind of irrelevant actually, I don't need it. It's not going to do anything. I need to set each of these factors equal to 0. So x plus 4 equals 0, 2x minus 1 equals 0. So one of my solutions, negative 4, the other solution, add 1, I'm running out of room, so 2x is equal to 1, divide by 2, so my other solution would be 1/2. So those are my two solutions there. Alright, that one took a little bit of work. 8. Negative 6x squared plus 7x plus 3 is equal to 0. It's already in the correct form, but first term is negative, so I do have a negative 1 for the GCF that I'm going to have to factor out. So I got negative 1, 6x squared minus 7x minus 3 equals 0. So this is what I want to factor. So I'm going to set up my cross here. A is not 1, so I am going to have to use grouping. So A times C is negative 18, B is negative 7. Two numbers I'm looking for are negative 9 and positive 2. I'm going to use those to split up negative 7 into negative 9x and positive 2x. And then I'm going to group these first two together and group these second two together. So my first group would be 6x squared minus 9x. And my second group would be 2x minus 3. I'm going to factor the GCF out of each of these groups. GCF of the first group is 3x. GCF of the second group is 1. So 3x comes out of the first group, 1 comes out of the second group. I'm left with 2x minus 3, 2x minus 3. So my factored form, 2x minus 3 is the first factor, 3x plus 1 is the second factor. And don't forget about the negative 1 that we started with. Actually, it really doesn't matter if you forget about it because it's not doing anything when we're solving. It is part of the factorization, but it's not doing anything when we're solving. So these two are what are doing something. This one, 2x minus 3 is 0, or 3x plus 1 could be 0. So our first, one of our solutions, add 3. 2x equals 3, divide by 2. One of our solutions, 3 over 2. The other solution, minus 1, 3x equals negative 1, divide by 3, x equals negative 1 over 3. It's my other solution. So these would be my two solutions. Alright, next section. Number 9 says write a quadratic equation in standard form with the given roots. And the roots that it gives me are 0 and 5. So if I wrote this in factored form first, it needs to be in standard form, but if I wrote it in factored form first, 0 implies that x is one of the factors, and 5 implies that x minus 5 is one of the factors, because 0 would make this factor 0, and 5 would make this factor 0. So my equation, first factor is x, the second factor is x minus 5, and together they make 0. If I use the distributive property, I can put this into standard form. X squared minus 5x is equal to 0. This is an equation that has solutions 0 and 5. Number 10, we want a similar one with negative 3 and 7. So negative 3 would mean that one of our factors is x plus 3. 7 would mean the other one is x minus 7. So I just need to multiply those together, set it equal to 0. So I'm going to use the distributive property to figure out what this would be in standard form. So x times x is x squared, x times negative 7, negative 7x. 3 times x is 3x, 3 times negative 7, negative 21. Combine the like terms, negative 7x and positive 3x, x squared minus 4x minus 21 equals 0. This equation has solutions negative 3 and 7. Alright, the next section we're simplifying the radicals. So the first one we need to simplify is negative 18. Alright, negative not inside the radical, so this does not have an I or anything. We just need to simplify 18, so we need to split it up into perfect squares. So a perfect square factor of 18 is 9, so we can take the square root of 9. The square root of 9 is 3, so this would simplify to negative 3 square root of 2. 12, square root of negative 16. Alright, so this is a negative under the radical. This does mean this is going to have something to do with I. So we're looking at square root of 16I, and the square root of 16 is 4, so this is just 4I. Square root of negative 28. Alright, well we need to take care of that negative sign. So this is square root of 28I. And when we want perfect square factors of 28, and 28 can be expressed as 4 times 7, where 4 is a perfect square, and the square root of 4 is 2, so this would be 2 root 7I. 14 is 4 square root of negative 36. Alright, well, this would be 4 square root of 36I to take care of that negative symbol. Square root of 36 is just 6, so we'd have 4 times 6I, which is 24I. 15, negative 3 square root of negative 27. Alright, well this negative isn't really doing a whole lot. We got negative 3 square root of 27I to make up for the negative symbol. We can rewrite square root of 27 as 9 times 3, because 9 is a perfect square, and I can take the square root of 9. The square root of 9 is 3, so I have negative 3 times 3, and then in the radical, I still have a 3, because I took the 9 out, I, which negative 3 times 3 is negative 9, so negative 9 square root 3, I. Alright, the next section has to do with the cycles of I. So the cycles of I to the first power is just I to the second power is negative 1, I to the third power is negative I to the fourth power is 1, and then they repeat themselves. This would be a remainder of 1, remainder of 2, remainder of 3, and then divisible by 4, remainder of 0. So for 16, I have I to the 7th, which would be, if I divide 7 by 4, I would get 1.75. So 7 divided by 4 is 1.75, which we can see right here is the third one, so this reduces to negative I. (17) I to the 25th power. So 25 divided by 4 is 6.25, so it's a remainder of 1. It's the first one, so this reduces to I. (18) I to the 183rd, sorry, I'll put a 4. It says 183rd power. So 183 divided by 4 is 45.75. The 75 tells me that it'd be a remainder 3, so right here reduces to negative I. (19) I to the 76th power. So 76 divided by 4, 19 even, so 19.00. It doesn't have a remainder, it reduces to 1. Number 20, I to the 1030th power. So 1030 divided by 4, 257.5. So 0.50, that's this one right here, so negative 1. Alright, for the next section, we're adding, subtracting complex numbers. So number 21, we have 3 minus 5i plus negative 8 plus 9i. Alright, all we have to do here is add the real portions and then add the imaginary portions. So 3 plus negative 8, negative 5. Negative 5 plus 9 is 4i. (22) 7 plus 3i minus negative 2 minus 6i. Alright, here we're just subtracting the real part, subtracting the imaginary. 7 minus negative 2, 7 plus 2, that's 9. 3i minus negative 6i, so 3i plus 6i is 9i. (23) 4i, negative 7i, and I. So 4 times negative 7, that's negative 28. I times I times I, that's I cubed. But we remember from our cycles of I that I cubed is just negative I. Sorry. I cubed is negative I. So this becomes positive 28i. (24) This is multiplication. 6 minus 7i, 3 plus I. We're going to use the distributive property to multiply these. 6 times 3 is 18. 6 times I is 6i. Negative 7i times 3 is negative 21i. And negative 7i times I is negative 7i squared. But remember, I squared is negative 1. So this is actually negative 7 times negative 1, which is positive 7 or plus 7. Alright, so we add the 18 and the 7, so that's 25, and we combine the 6i and the negative 21i, which is negative 15i. 25, 2 plus 7i times 2 minus 7i. You should recognize right off the bat that these are complex conjugates. Your sum or product should be a real number. So I'm going to use the distributive property. 2 times 2 is 4. 2 times negative 7, negative 14i. 7i times 2 is positive 14i. And then 7i times negative 7i is negative 49i squared. Well, the i's are going to cancel. I squared is just negative 1, so this just becomes positive 49 or plus 49. So what we have is 4 plus 49, which is 53. So number 25, our sum is a real number. 26 is division, 5 divided by 2i. This requires us to multiply the numerator and denominator by the complex conjugate of 2i, which is negative 2i. It doesn't have a real part, so the real part always stays the same. So 5 times negative 2i is negative 10i, and 2i times negative 2i is negative 4i squared, which is negative 4 times negative 1, which is positive 4. And this is still a negative 10 up top. And we do want to simplify this or reduce it. So this reduces to negative 5 over 2i. This is just imaginary. There's no real part to it. (27), we have 1 minus 3i over 2 minus 5i. We need to multiply the numerator and denominator by the complex conjugate, which is 2 plus 5i. The real part stays the same, but the imaginary part is opposite, so 2 plus 5i. We're going to use the distributive property to multiply the numerators and denominators. So 1 times 2 is 2. 1 times 5i is 5i. Negative 3i times 2 is negative 6i. And negative 3i times 5i is negative 15i squared. Same thing in the bottom, so I'm going to use the distributive property. 2 times 2 is 4. 2 times 5i is 10i. Negative 5i times 2 is negative 10i. And negative 5i times 5i is negative 25i squared. Alright, let me simplify some of this stuff. Alright, so negative 15 times I squared is negative 1, so this just becomes plus 15. Same thing with this minus 25i squared, this just becomes plus 25. These i's cancel, so my denominator 25 plus 4, that's 29. My numerator, I have 2, and then 5i minus 6i is negative I. Alright, now I do want this in the form of an actual, complex number. So I'm going to split the denominator to each of them. So 2 over 29 is the real part, minus 1 over 29i. Or I over 29. Not super important how you write that one, but this is best, because now you can clearly see the coefficient of the I term is negative 1 over 29. Alright, 28. We are solving for x, so this means taking square roots. It could mean other things, but we're doing taking square roots. So get the x squared term by itself. Divide by 3 after you subtract 48. So we got x squared equals negative 16. Square root both sides. Don't forget about the plus or minus sign, because we will have two solutions. So square root of x squared is just x, and then we have plus or minus square root of 16i, which is just 4i. So we have two solutions. X is 4i, and x is negative 4i. (29) X squared plus 121 is equal to 0. Get the x squared by itself, so minus 121. X squared equals negative 121. Square root to get rid of the square, don't forget plus or minus. So x is equal to plus minus, square root of 121 is 11, and then the I because of the negative. So we got two solutions. X is equal to 11i, and x is equal to negative 11i. Number 30, we're finding values of x and y that make the equation equal. So we have 4x minus 1 plus y minus 2i equals 5 minus 2i. Alright, so we need the real portions to be equal to each other. We need the imaginary portions to be equal to each other. So the real portion on the left side is 4x minus 1. And the real portion on the right side is 5. So 4x minus 1 has to be equal to 5. For the imaginary part, y minus 2 is the coefficient of the imaginary part, and that needs to be equal to the coefficient of the imaginary part over here, which is negative 2. So y minus 2 needs to be equal to negative 2. We can solve these to figure out what x and y need to be equal to. Add 1, divide by 4. So x is equal to 3/2. And then y, add 2. Y has to be 0. Using these values, the equation will be true. Alright, thanks. Good luck on the quiz. Good luck.